Okay, in this activity, we're going to be working through using a ratio table and a graph to determine whether or not we have proportional relationships. So first of all, to explain kind of what's going on in this picture, we have time in seconds and height in meters. So this is maybe something that's going up in height over a period of time, maybe like a hot air balloon or maybe just a regular balloon or something like that. It says the structure in the ratio table shows why the graph has a constant rate of change. So you'll notice that constant rate of change means that it's consistently going at the same pace the entire way. So you'll see with this line how it's a perfectly straight line going up. It's not jig-jagging up and then up and down and up and down again. It is a perfectly straight line. So that is one thing that in order for two rates to be considered proportional, it has to have a constant rate of change. The other thing is it must also pass through the origin. So if it has a constant rate of change, a perfectly straight line, and it passes through the origin, well, the origin is that 0, 0, then it is considered to have a proportional relationship. And you'll notice from looking at the table that we do see that it's changing constantly by adding 3 on each of those, where our y's are changing by 2 meters for each of those different scenarios. So there's that constant rate of change. The graph on the right-hand side is just going through and actually plotting these as sets of coordinates. So if I were to go through and kind of look at this, I would look at this as 3, 2. So I'd go over to 3 and up to 2 and put my dot. So that notice that that's where the line is. The second one was 6, 4. So over to 6 and up to 4. So there's my second set of coordinates. 9, 6, over to 9, up to 6 is that point right there, and so forth. So you can see that all they've done is taken that table and they've plotted it as coordinates. So that's kind of what we're going to work on today. The two key things to remember: you must have a straight line, and it must pass through the origin or pass through 0, 0. Okay, so let's go ahead and work a couple of these out. Okay, so it says determining whether two quantities are proportional. So once again, straight line and pass through the origin of 0, 0. So it says use a graph to tell whether x and y are in a proportional relationship. So we could check off of the table to see if they are consistently changing. So like here it looks like we're adding 2. 4 plus 2 gives us 6. 6 plus 2 gives us 8. 8 plus 2 gives us 10. So it looks like it's constantly changing. The key thing is it would have to also change to the point where it would go through 0, 0. So sometimes that's just easier to actually see in its graph format. So if I were to plot these, when I plot these, this right here is my set of coordinates. Notice that this is set up differently than the previous one. I had them left to right. Here they are top to bottom. So if you would prefer to see them, that 2, 6 that I have circled left to right would look like that. So I'm going to go over to 2 and up to 6 and put my dot. Okay, the next one right here, 4, 8, over to 4, up to 8, put my dot. And the last one, 6, 10 would be that, over to 6, up to 10. Okay, so it looks like it's making a nice straight line. So if I were to connect these points, the question is, would it cross through 0, 0 if I were to continue that through? Our origin is actually right here. Does it cross through our origin? No. So when it says use the graph to tell whether x and y are in a proportional relationship, the answer to this one would be no. And the reason that we eliminated that, it does not cross through the origin. Okay. The way you could check that off of a table is you could continue the pattern working backwards up here, if you would prefer to do that. Otherwise, these types of problems, you guys are going to be using your whiteboards to check yourselves. But I could work backwards off this and say, okay, it's -2, -2, -2. So then 2 minus 2 would give me 0. So there it would cross through 0. But if I checked the pattern here, So 6 minus 2 would give me 4. Take note, that's this point right here. Over to 0 up to 4. So I did not have a 0 in that position there, so therefore I could tell from without having to graph it that it was not going to cross through 0, 0. But you guys are just learning. Sometimes having that visual is a little bit easier. So let's go ahead and try the second one. Okay, so here's our first set of coordinates. 1, 2, which would look like this, left to right. Over to 1, up to 2, put my dot. Okay, the next one I have is 2, 4. So over to 2, up to 4. And the last one, 3, 6. Over to 3, up to 6. And now I'm going to go ahead and connect my points and see if it crosses through 0, 0. And it does. So in this situation, they are proportional because they increase by the same amount on each of the X's and Y's. Creates a straight line visually. It also crosses through 0, 0. So would this be proportional? Yes. It crosses 0, 0. Also known as the origin. And it changes constantly, has a constant change. Okay, if you wanted to check that without graphing it, well, once again, you'd want to work backwards to see if it would cross through that 0, 0 since it's not giving us that as an option. So to get from 3 to 2, you would go minus 1. 2 to 1 would be minus 1. So then 1 minus 1 would give us 0. And then we would check here. From 6 to 4 would be minus 2. 4 to 2, minus 2. 2 minus 2 would give us that 0. So we could see there that it would actually cross through 0, 0 if you're wanting to check it without actually graphing it. Good luck with this, and the two key things to make sure. In order for it to be considered proportional, it must cross through the origin, which is 0, 0, and it must have a constant change of rate, which would be showing you a straight line.